Hello again. Naming organic compounds, one of those things that you have to be able to do. Kind of allows you to make sense of questions because they talk about the names of compounds. If you haven't watched the video about the types of formula, or if you're not familiar or you're not completely sure of the types of formula, I recommend you watch that one because you're going to make, it's kind of like assumed in here that you can do that. Now, first thing about naming is knowing how to show the number of carbons. But it's not as straightforward as that. It's the number of carbons in the longest chain of carbons rather than the number of carbons. They may be the same thing, but they don't have to be. Now, the GCSE thing is MEPB that you've got to remember. And you're still in the same boat. You have to know that it goes MrEV prop but. I've had this thing with monkeys eat peanut butter, monkeys eat peeled bananas, all sorts of things. A friend of mine came up with a banana one and she was very proud. She's a biologist, these things happen. And MrEV prop but, 1, 2, 3, 4. If you can't remember that, you're kind of setting yourself up to be stuck. And similarly with what comes after. So this is the longest chain count. 1, 2, 3, 4. Then you get into the things that you kind of should be more familiar because of the mathematical shapes thing with pentagons and so on. So 5, hex is 6, hept less familiar with, but it's 7, oct is 8. Non, again not necessarily something you're particularly familiar with, is 9. Dec, as in decimal, is 10. A-level tends not to go past dec. In fact, most A-level courses don't go past, they don't have molecules with names past 6, but you need to be kind of aware just in case. And then once it goes past dec, it gets a bit more cumbersome because it goes undec, dodec, tridec. And too many to think about there, but that would be undec is 11. So these are the way to specify the length of the longest chain. Then there's an ending. So we're going to have a board with all the endings on. I'm going to prep that up in just a second. And you start to be able to put those together and you get the actual names of compounds. But then there's further things you need to be able to do to specify where things are. But I will see you when I've got the board sorted for what the endings are. See you in a moment. So endings. Endings tell you important things about the structure when you have a name. Of course, you need to be able to do both. You need to be able to look at a structure, give it its name, or get a name, draw the correct structure. You know, they are the interchangeable skills. ANE. ANE, GCSE version is, that means alkane. Not quite what it means. It often means that, but it doesn't have to. It means saturated. So it will be an alkane because alkanes are saturated. But if you swap the hydrogens for other things in certain places in what would have been an alkane and then you swap some of the things, it remains saturated because it hasn't got any double bonds that the next one does. So if it is saturated and there are no multiple carbon-carbon bonds, it will end in ANE. So you will have structures that end in ANE. ENE as an ending means you've got a carbon-carbon double bond and it is therefore unsaturated. But it does specifically mean the carbon-carbon double bond. This is that kind of take the notes section, isn't it? Stop me, rewind me if you need to get the notes from earlier if you didn't do it. OL at the end means alcohol. Now don't get mixed up with AL, it means something else. So alcohol means it ends in OL. Now there is a little bit of an annoyance, for me it's an annoyance because although there are hard and fast rules with this naming thing, and the naming system originated from, there's an overseeing body of chemistry called Iupac, International Union of Pure and Applied Chemistry. And they set the naming rules in 1969. Prior to 1969, it was chaos. It was just, if you don't know what this name means, you're just totally and utterly stuck. You'd have to go and look it up. And we had no internet in 1969. I was 8. So the system of Iupac gave us a set of rules for naming things, and these are some of the things within it. But one of the confusions in it is sometimes you put the E on the end of the stem, sometimes you put an A, sometimes you put an N. Oh, you kind of just have to be familiar enough with it, I think, because it's just too hard to remember the ins and outs of all of that. So we have this set of endings that mean things. Now, one of the irritations is that the whole world uses, since 1969, the Iupac naming system, unless you live in the United States of America, where you just ignore it and do whatever you felt like it was before, which makes chemistry impenetrably difficult. Oh, I never understood why that would be the case. So we live with a compound called propan-2-ol, which tells you that the OH is on the second carbon, as we'll do when we do some naming. And in America it's called isopropanol. Helpful? No, not really. So alcohol, OL on the end. ONE is a class of compounds called ketones, part of the A-level course. Maybe you're not familiar with the concept yet, but this is one of the endings that you need to know. AL means aldehyde, not to be confused with alcohol, because you can, although you can turn that into that. So there was a bit of even further confusion in there. So AL means an aldehyde, not an alcohol. Oic acid means a carboxylic acid. Now you should be familiar with carboxylic acids from the work on esters with reactions of carboxylic acids at GCSE, and carboxylic acid when it ends in oic acid. And finally, a new thing that you will see from time to time, OYL, oil chloride, which is the class of compound is called an acyl chloride. That's a bad L. Acyl chloride. Not so much at the early stages of organic. I just thought we'd say that there's a whole load, and there's a whole load more. I mean, there's a whole bunch more. If you look at the world of chemistry, there are probably, at a guess, 7.5 million compounds that people have put a name to. At least 6.5 million of those are organic, meaning they're based around carbon. You're going to need a system that allows you to identify what you've got. Most importantly, if the molecular formula is the same but there's more than one isomer, the name cannot be the same. So you need a naming system that reflects the fact that the isomer needs its own unique name. And that's done with numbers a lot of the time. And we're going to get onto that very shortly. You might notice that something like a chlorine attached to an alkane is not in here. That's because the way that is named is not via the ending. And we'll do some range of examples, I suppose. We'll do some examples including that very soon. But I'm going to get the board ready for the next bit, and I'll see you in a moment. Okay, some rules. I would imagine the Iupac rulebook is somewhat larger than this, because I kind of pared it down to just 3 things with some sub-steps here. And overall there's a whole load of other rules. But we have to draw a line at some point in A-level to say this is as far as you need to go with the naming. So find the longest chain, definitely the most important thing to start with. Find the longest chain. That will define that MEPB, pen, hex and so on. That's that bit. Define the ending based upon what the structure looks like. So this is where you look at the overall picture and go, oh, that's an alcohol, I'm going to end it with OL or whatever is appropriate. And then you get on to specifying positions, and there's a whole load of bits and pieces about that. So you never specify a hydrogen. The whole point of this is that hydrogens are just there. So you specify the position with a number. And when you do the numbering has to give you the lowest total. If there's only one number, it has to be the lowest number. Why does that happen? Because you could number, if you had a molecule written left to right, you could number from the left or you could number from the right. And whichever way you go that gives you the lowest is the way that you do it. So if you came from one end and it was 2, and you came from the other end it was 3, it would be 2. The 3 would be wrong. When you move from a number to a number, you put a comma. So if there's two numbers next to each other, it will be 2, 2, for instance. If you go from a number to a letter, so when you come off of the number and you go on to some words, it has to be a hyphen. There is one exception to that later on when you do what's called geometric isomers, but there's a different video, there's another video about that somewhere else on my channel. Not ready for that yet, we're at the early days of naming here. And lastly, when you've got more than one thing, like you've got a bromo and a chloro, here's an example, there, chloro. These are called prefixes because they go before the meth or the eth or the prop and all that kind of thing. They go alphabetical, so bromo comes before chloro, chloro comes before methyl, and so on. So you have to have them in alphabetical order. Often people forget that and they get the name wrong. You get a multiple choice question, and one of the things they'll do in a multiple choice thing where it asks you to, what's the name of this substance that they've drawn out, is they'll have it not in alphabetical order. Everything else will be right, but it will be chloro before bromo. There's a cliff, don't fall off it. We're going to do some examples to give you some idea, and then there'll be some follow-up questions for you to practice on. But I need to get the board ready for some examples, see what I say. So here's some fairly simple examples, just to get us in the way of doing it. We've got the reappearance of kittens, who are somewhat bigger than maybe last time you saw them. They're a bit of a law unto themselves now. They were out just now, but they're back in since we stopped filming the previous segment. The top one there, so how do you name it? You go 4 carbons in a line, 4 carbons in a line, BUT, no double bonds, his name is butane, he doesn't need anything else. Here, skeletal formula, need to count how many carbons it is, 1, 2, 3, 4, 5, 5 means pent, because they're all in a straight line, so 5 in a line, pent, no other features, pentane. Here, how many carbons? 1. By definition, there can't be a carbon-to-carbon double bond because of any other carbon, so it's got to end in ANE because it's saturated, and it is chloromethane. There. Now here, 2 chloros. So this would be, and this is something that you need to do, if there is more than one of the same thing, you have to indicate that with di, tri. You'll notice there are no numbers in this because they can only be on the carbon, there's only one carbon. So implicit in what we just said there is di, tri. When you get to 4, it's tetra. It's not quad, it's tetra. And the last one here, now 2 carbons, no double bond, so it's ethane, the name is based around. It's dibromo because there are 2 bromos, but we have to say where they are. Why do we have to say where they are? Because you could have had them both on one of the carbons and not one on each, or you could have what you've got here, which is 1 on each. So that means 1,2 hyphen dibromoethane. There's a little bit run out of space there, but it's 1,2 hyphen dibromoethane. That tells you that there's 1 on the first carbon, 1 on the second carbon, or 1 on each. And there we are. We're going to do a few more slightly complex examples just to increase our skills, but I'll see you in a moment. So, 4 further. I hope you're stopping the video, writing these down and making some notes, because if you're not, this is kind of like a waste of time. You really need to backtrack and do that. It's an alkene this time. How many carbons, first of all? 1, 2, 3, 4, 5. So, pent, 4 bonds, 5 carbons. It's not pentene because these two substances, same molecular formula we don't tell you what your name's going to be unless it's CH4. So they need a different name. So this is pent 1-ene. That's pent -1-ene because letter to letter. Hyphen between number and letter, in whichever order you do it. This one here is pent 2-ene. That's because 1, 2, 3. If you number the hydrogen, no, don't number the hydrogen, you number the carbons. The double bond starts on carbon 1, so it gets a 1. I know it goes to number 2, but it isn't 2 because this is 1, 2, 3. So it goes between 2 and 3, so you give it the lowest number, which is 2, so it's pent 2-ene. We don't number it from the other end because it would be 4. And we had a rule about not going for the higher of the two, you want the lower of the two. This here is propene. We would need an R if it's going to be propene. Propene. No number. Why? Because if you move the double bond position, it's still the same substance, it's just the equivalent of going around the back and having a look from the other side. Now this, a little bit more complicated, not massively. Longest chain of carbons, 1, 2, 3, 4. That's the wrong way to do it because you have to include the major feature. So it's 1, 2, 3, 4, but the numbering would go the other way because that means that we get a 1 here, not a 3. We don't want a 3, we want a 1, which is lower. So the longest chain, not sure I've got enough space to write that in there, But-1-ene. No? So But-1-ene, that's that. But we've got this here. That's 1 carbon's worth with 3 hydrogens around it. That's a methyl. But we have to say where that is. And when you go from a number to a letter, you have a hyphen. So it's 2-methyl-but-1-ene. Or 2-methyl-but-1-ene. There you have its name. We're going to do some more examples. I'll see you in a moment. So slightly more complicated molecules again. 2,4-dimethylpentane. Skeletal formula again. Kind of a big fan of skeletal formula, saves time. 5 carbons. I've gone from numbering this way. It actually doesn't matter which way you number this one. And the methyl here is on the 2 and the 4, so it's 2, 4. It's pentane because the longest chain is 5. 5 in the longest chain. Here, the next example, there are 6 carbons in a line. So it's going to be based on hexane. There's no other features. So the only thing is you need to specify there's a bromine and a chlorine. Bromo and chloro on the 2 and the 3. Bromo before chloro alphabetical. And the last one, you can loop round and join the chain back up to itself and get a cyclic structure. So this is 6 carbons in a ring, so it's cyclohexane. There we go. There's a cat probably popped behind me, I don't know. They're roaming around the sofa. I'll see you with the last lot of examples and then you'll be free to have a practice. See you in a moment. So, increasingly complicated. Here's just an alkane. Longest chain. Got to think, do you go down the side chain? This is a side chain. Or do you not? Depending on which gives you the largest count. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So 7 is the longest. That makes the name hept. And it's an alkane, so it ends in A-N-E. So that's the 7 straight across. There are 3 additional ones. Now we had a methyl before, which was 1 carbon CH3 group. Now we've got CH2, CH2, CH3. That is propyl. You see, you need to not be getting stuck on the meth, eth, prop, bute, pent, hex. That needs to become second nature, because otherwise the naming thing becomes a stumbling thinking, oh, I've got to remember all these things. You just need to be you need to get very familiar with it. So propyl hexane, but you have to say, where is the propyl? 1, 2, 3, 4, that would be on the 5th carbon if you came in that direction. 1, 2, 3, 4, 5, I'm going to go to 5, so it would be 3 if you came numbering in that direction. So the lowest version of that is 3 propyl heptane, because it isn't 5 propyl heptane, because that's wrong, because the 3 is the lowest version of that. So then, looking at this here, this one's written in a tricksy way. 1, 2, 3, 4 straight across would be butane. 1, 2, 3, 4, 5 down the side chain. Well, that makes it a pentane, not a butane, because it's not about how it's written, it's about where's the longest chain. Pentane. So that means the longest chain, 1, 2, 3, 4. I'd love that to have been a 4, but I wrote a 5. There we go. 1, 2, 3, 4, 5. So that means this little dotted bit is the additional carbon content. So it's on carbon 2 as well, because it comes off of the second carbon. There's a bond going to go in there, would be in there. You don't put it in the structural formula. So it's ethyl pentane. And you have to specify where the ethyl is. So the ethyl, which is here, is coming off carbon 2. So it's 2-ethyl pentane. It's not numbered in the other direction, 1, 2, 3, 4, because it's not 4-ethyl pentane. That's wrong, because you need 2, because the 2 is lower. So here we are, 2 alkanes named. Slightly shoddy looking 4, but there we are. Then we come to this skeletal structure. 3 things to consider, as you will see. So first of all, longest chain, 1, 2, 3, 4, 5, 6 versus 1, 2, 3, 4, 5, 6. So which 6 is it? Because if you went this way, 1, 2, 3, 4, 5. So it's not that one, that's not the longest chain. So it's 6. And it's the ones with the actual functional groups that are important enough to get a name in the molecule. So 6 that way isn't as important as 6 that way. So hexane, because it's an alkane, there's no double bonds. And then we've got to consider fluoro, iodo, and then you've got these 2 here, which is ethyl. And you've got to look at the numbering system. So do you number it from this end? Or do you number it from this end? I'll pick up a different colour pen, hold on. So 1, 2, 3, 4, 5, 6. So those 2 carbons there are the ethyl there. So if you go in with the blue numbers, the fluoro is 5, the iodo is 3, and the ethyl is 4. And you add that lot together, you get 12. If we go with the red numbers, the fluoro is 2, the ethyl is 3, and the iodo is 4. And that adds up to 9. So the red is correct, the blue is wrong. So that makes the name, I haven't got enough space to write it in there. So I'm going to try and squeeze it in. Now immediately I've gone and done the wrong thing, because you have to go alphabetical. I went for the 2 because it was the number, the lowest number. That's the wrong thing to do. Alphabetical, what's first? E, F, I in that order. So it's 3 ethyl, 2 fluoro, 4 iodohexane. I knew there wasn't going to be enough room. Now that's a massively complicated name compared to where we started, but if you've kept up with it, that should make sense. And there you have them, EFI, hexane for 6. Now you also have to be able to draw them out in the other order, in the sense that you get a name, what is the structure? But that's kind of an easier skill than actually constructing a name. And there'll be both types of example in the follow-up questions that will be attached to the video. So thank you for watching, and I look forward to seeing you for more adventures in organic chemistry, quite frankly, because that's the videos we're making at the moment. I will see you soon. Bye-bye.